Otis Brown. This is John Brannock. We're going to talk a little bit today about the big data project data broker role. We think. There it goes. Okay, as you can see, and it was pointed out, I think, by Dan in the last session, that we're in this sort of interstitial between the archive and the public data clouds. And so our role is to try to act as an impedance matcher between each side of the transfers. It has to do with protocols, it has to do with cultures, and somehow make sure that data moves from the federal archive to the CRADA partners. We resolve operational problems. We try to ensure data integrity. We can certify CRADA partner holdings, and we play a role in adding new data sets. Part of the operations include, well, what happens when data doesn't move? So source data outages, in some cases that means resolving source or destination outage causes, resolve transmission errors, maintain 24/7 operations with minimal data loss, and as I said before, add new data sets. The currently brokered data sets by the Cooperative Institute include the GOES 16 ABI and GLM, GOES 15 GVAR, NextRad Level 2, GHCN Daily, National Water Model, Ocean Forecast System. You can see that's about 2 terabytes of data a day that's moved to the cloud. And the cloud providers are noted in the third column and the sources in the right-hand column. And you can see it's from across NOAA. Now, to sort of move this discussion forward, there are a number of other data sets being considered, and this is only the tip of the iceberg right now. NOAA 20 VIIRS day-night band, GOES 17 ABI and GLM when it becomes available, the water level station data from around the country, the high-resolution rapid refresh forecast data, the climate forecast system data. You can see that this will greatly expand the amount of data holdings as well as the needs to move data from one place to another. A lot of policy issues have come up as we've been doing this. Amazon asked us to look at format conversion. We picked a trivial case. It turns out that the GHCN daily granules are gzipped, and people, the consumers said, well, we really like comma-separated variables, so can you do that? So we use Lambda functions in this case, and it mostly works, but as you know, there are some limitations to the amount of memory you can use and the amount of time it takes to do. Outcome of this process has been that most reasonable conversions that we've been asked about are going to require separate cloud instances. They're not going to be doable through a standard Lambda architecture. We've discussed moving NetCDF imagery into cloud-optimized GeoTIFF. Part of this discussion today is to understand what is it that the user wants on this end of the thing. NOAA is into NetCDF and not cloud-optimized GeoTIFF. GRIB2 data matrices, should these be in NetCDF? Should they be in rows of separated parameters? In other words, is this something that we should really be using as the sort of first wave, as you've seen in the first session this morning from Cornell, of where everything's being put into rows? Different sort of policy issues came up when the National Water Center requested that we look at the order of about 20 plus terabytes of data and remove one parameter from every data set. We use the web services Fargate, launching a pile of Docker containers Took it about 26 hours to go through and do it. But of course, this raises some other questions like the policy considerations associated with it. In the case of the removing the parameter, who certifies that data set now? We had to go back to the NOAA. We went back to the NOAA subject matter expert and said, okay, you certify that this is what you wanted to have happen in the cloud representative version of this data set. And the answer was yes after a few days. That was certifiable. But as we look at conversions and updates, and particularly changes in format, who's going to either provide validated source code and engineering for the cloud instance, who's the certifying authority, who's the certifying authority for an updated new data set. And you might ask yourself, do you even care? Okay, when we started this, one of our assumptions at the time was that the cloud partners, because we asked, mostly said they didn't care. They figured if it was a big problem, the customers would say it was a problem, and then we would look at it. Well, now it's a policy issue. Timing. Given the way data sets are accessed, should this be performed for all data of a given class upon receipt of a request by NOAA? Or should it only be done on demand when a user asks for it? In other words, should there be a native cloud resident version that's only converted when somebody accesses it? And you can see why that might be an issue. And then they get into cost policy issues. Right now, it's not a driver, but we foresee it could be. Now, just to give you some ideas about what's been going on with Go16 and ways of looking at data statistics, and this is from Amazon Web Services. You can see that if we look at the accession ratio, and this is defined as to how much data did we put into AWS on a given day, and how much was either touched or moved somewhere else. So it could have been processed, in EC2. It could have been downloaded to somebody's workstation. There's lots of ways it could be accessed. But that's running about 9-to-1 right now. And you can see it's been fairly flat the last several months. Now, if we turn that around and say, let's look at authenticated users of a given set of data sets, because one of the questions that was raised with Go16 is the level 1 data set being accessed in a similar way as the level 2? And as you can see by this, it's kind of an eye test. You can see the various ABI products, and the black line on going from left to right is when the Go's Lightning Mapper was turned on. So you can see that that's coming up as time goes on. But the answer is that you see a ratio of, well, the number of accessors is somewhere, I don't know, from 20 to 70, depending on the data set. So there's not any one of the Go's product lines that you could say really no one is accessing. So that's not a way that you can try to stratify data set accesses, although the picture you get here is very different from this one, this 9-to-1. Okay, that's saying if I had to support a data service, I'd need 9 times as much throughput as I'm getting from people using Amazon one way or another. This one's saying that I'd have to manage a user community of anywhere from 20 to 70 additional people or corporations or whatever they are. It's a different problem, but it's still a management issue if you're NOAA. So this is looking at it from a NOAA-centric point of view, saying, okay, what kind of problems are we avoiding by going to this cloud resident data set? Now, This slide, this is my last slide actually, I'm way ahead of time, is probably the biggest surprise, I think, to us and to AWS. Because if you look at the color of the bars, the bars are really trying to say who has looked at the data in near real time, that's the blue, and then work your way up to the top bar, which is about 20%. Who's looking at Go 16 data after it's a day old? So there's a significant amount of access of Go 16 data a day after the fact. We have no idea why, but there is, or a day or more. If we were to do something similar for radar data, you would not see this picture. At the 95% level, it would be within minutes. So so the message that we took away from this particular analysis is that each data set is unique and each user community is unique. And you've got to understand the characteristics of that community. There's not a one-size-fits-all metric for cloud resident data sets. Thank you.